GPT-4 is an impressive language model that can generate text on any topic in any style and in almost any language. But it's not flawless. It can also produce errors, such as inventing facts, repeating itself, or going off topic. How can you learn to work with GPT-4 and make it do what you want? The key skill for working with these models is called prompt engineering. OpenAI just released their 6 steps towards better prompt engineering. Let's go over them and talk further. Hey guys, I'm Ian Wong, a Duke University critical care doctor and health informaticist. In this video, let's review these tips that OpenAI has given us on prompt engineering. There are 6 strategies for getting better results. Let's go over them. Be specific or be sorry. The first strategy for prompt engineering is to write clear instructions. This may sound obvious, but it's actually really important and often overlooked. These models aren't mind readers. They don't know what you want unless you tell them. If you gave them vague or ambiguous instructions, they'll have to guess, and they may guess wrong. Imagine when you first got a poorly specified project from your teacher in school. Same thing, just writ larger. For example, if you write a poem about OpenAI, they might have to write a long, boring, or nonsensical poem because you don't have any idea of what kind of poem you want, how long it could be, what tone it could have. On the other hand, if you ask them to write a short, inspiring poem about OpenAI on recent updates in the style of Dr. Seuss, they could have a much better idea of what to do. So let's go over the tactics here under write clear instructions. And tactic 1. Include details in your query to get more relevant answers. The devil's in the details. This is related to the previous slide where we talked about being specific or being sorry. Details help the model narrow down the search space and focus on what you really want. These could be keywords, categories, or modifiers that specify your preferences, criteria, or constraints. Highly relevant responses would require important details or context. So, instead of asking, for example, summarize the meeting notes, give it context. Summarize the meeting notes in a single paragraph. Then write down a markdown list. Finally, give the next speakers and steps that are action items identified, if any. Or how do I add numbers in Excel versus how do I add up a row of dollar amounts in Excel? I want to automatically do this for a whole sheet of rows with all the columns, right? So you see how the incomplete prompt on the left can be better specified with details and context on the right. Tactic 2. Ask the model to adopt a persona. Who do you want to talk to? The second tactic for writing clear instructions is to ask the model to adopt a persona. A persona could be a style, a tone, or a fictional character that could represent this style, tone, or perspective. The persona could help the model generate more consistent, coherent, and creative outputs because it gives a clear direction and sense of identity. It's hard to say, write some English poetry versus write poetry like Shakespeare. You can also make outputs more fun and engaging because it adds a personality and flavor to the text. So the lesson is, who do you want to talk to? A system message, like here, could suggest that you might want to reply with the example OpenAI provides is replying the document with at least one joke or playful comment in every paragraph. So again, suggesting you have a more jovial persona to adopt. Tactic 3. Use delimiters to clearly indicate distinct parts of the input. Separate but equal. Delimiters are symbols or words that really mark the boundaries or different parts of the input, and it can help a model parse the input more effectively and easily. They reduce the ambiguity or complexity of the input. Think of when you received a whole bunch of garbled text versus having something that's clearly marked out. They can also make an input more readable and organized for both you and the model. And delimiters could be dashes, colons, quotes, or even key strings or phrases such as HTML blocks. So for example, you see here 3 double quotes, you see here HTML or XML tags, and you also could have section titles like abstract and title like you see here. So separate but equal. Use delimiters when you want the model to parse the input more easily and accurately. Step 4. Break it down. Specify the steps required to complete a task. Some tasks are too complex or vague for the model to complete in one shot because it can involve multiple subtasks, variables, or decisions. Breaking down the task into smaller and simpler steps helps the model to perform better because it reduces the uncertainty and load of the task, and it can make it more manageable and structured for both you and the model. For example, These steps that are explicitly written out make it easier to follow. The lesson here is break it down. Lessons can be numbered, bulleted, or nested, and to make your task more clear or simple. If you have vague tasks or complex tasks, try using this tactic. Tactic 5. Show and tell. Provide examples. Examples can help the model understand the task and the desired output better because they demonstrate both what you want the model to do and how you want the model to do it. Examples could be input-output pairs, templates, or analogies to illustrate the format. These could also be positive or negative examples that show what the model should or should not do. For example, a model can't guess if you want to respond to user queries in a certain style. So by showing an example, you get to do what we call few-shot prompting, where you have a couple examples, again, a few shots that you've seen and that you can also replicate. So you have references. If you try to write an answer without references, you might have vague or complex results. But if you have a more clear task with references, that makes your job so much easier. Tactic 6. Measure twice, cut once. Specify the desired length of the output. The sixth and final tactic for writing clear instructions is to specify the desired length of the output. Length can affect the quality and relevance of this output because it determines how much information and detail the model should include or exclude. Too short or too long outputs can be incomplete or redundant because they might miss what you're trying to get at. Furthermore, too short outputs could also be vague or ambiguous, and too long outputs could be boring or confusing. Some examples that you have are, on the left if it's too short, on the right perhaps it could be too long. So some examples could be, for example, saying you have 50 words, or summarize into 2 paragraphs or 3 bullet points, again, based upon the need that the system can respond to more effectively. Let's move on to strategy 2. Don't reinvent the wheel. Provide reference text. Reference text is a piece of text with relevant information or examples, and so you can help leverage existing knowledge to avoid errors or inconsistencies. I'm sure most of you have heard by now the issue with these language models and hallucination. So by using these techniques in strategy 2, you can help more concretely solve your problem. Tactic 1. Use what you have. Instruct the model to answer using a reference text. Sometimes the answer to your question is already in the reference text, and you don't need the model to generate a new answer. You just need a new model to find and extract the answer from the reference text. By instructing the model to answer using the reference text, you can have the answer extracted more quickly and accurately, because it tells the model where to look and what to look for. So perhaps you could direct it to a particular paper or reference text, like a book. You can also make the answer more reliable and consistent because it's simply extraction as opposed to a more complex issue of, for example, text synthesis. If you ask the model a question about a book, you might not instruct it to use a reference text and expect the model to have gleaned this knowledge elsewhere. This might give you a wrong or inconsistent answer. The tip that they also offer, as we discuss later, is that these models have limited context. There's a certain amount of memory or working space in the model's head that can be quite limited. So if you need to offer a long piece of text, you might have to think of using embeddings for what they call knowledge retrieval to do so efficiently. We'll talk more about this later. The example that OpenAI provides is using these articles denoted or saying I couldn't find an answer and giving the possibility that the answer was not found. Tactic 2. Give credit where credit is due. Instruct the model to answer with citations from a reference text. Sometimes the answer is not directly cited in the reference text, but could be inferred or derived from it using some logic or reasoning. However, offering citations helps the model to justify and explain the answer by looking at the reference passages. Instructing the model to answer with citations can help the model justify and explain its answer more clearly and convincingly, because it shows the evidence and the rationale. It can also make the answer more reliable and trustworthy because you've selected that reference source. For example, by offering both a document and the requesting a citation, or giving the option for insufficient information, you've offered the chance to cite these passages and to offer clear citations for the result. Now that we've looked into ways to use reference text, let's look into strategy 3. Divide and conquer. Split complex tasks into simpler subtasks. Complex tasks might require multiple steps or skills or decisions to complete, such as writing a research paper or solving a math problem or even planning a trip. By splitting a complex task into simpler subtasks, you will both help improve performance by reducing load and reducing uncertainty, and also makes the task more manageable and structured. So let's go over the tactics into this divide and conquer strategy. By splitting tasks into simpler subtasks, you can help build on the shoulders of giants to accomplish bigger and better things. Let's talk about 3 tactics to how to do this. Tactic 1, know what they want. Use intent classification to identify the most relevant instructions for a user query. This first tactic is to use this intent classification to identify the most relevant instructions. So by intent classification, you can figure out what the goal or purpose of this query is, such as asking a question, making a request, giving feedback, or just expressing an emotion. By using intent classification, you can help the model choose the most relevant instructions for a user query by telling the model what the user wants and what it could expect or should expect from the model. It can also make the query clearer and more consistent by reducing the ambiguity and complexity of the query. So, for example, you might say that by providing a system message of a query falling into a primary or secondary category, you get to structure the request a client might ask you by saying, okay, I need to get my internet working again. This sounds like it doesn't sound like it fits under a billing or an account management issue, but actually might fall under a technical support category. Within that category, that primary category, you have secondary categories. And it sounds like it's not that the device isn't compatible with something else's software updates, but it sounds more of a troubleshooting it. And then once you've categorized that initial query, you can then direct it to a secondary query by saying, okay, we've finished the initial work before. We've categorized this into a technical support general category with a troubleshooting secondary category. And then you can offer a standard user system message by then prefixing this system message into the next query and then parsing the result of, I need to get my internet working again. This is similar to thinking through a flowchart. For example, starting from the top, going through receiving an input, having a process to then decide where might this go, continuing this, iterating on this decision or process to figure out what path to follow until you get the desired output. And so following from top to bottom, which path to take. Tactic 2, keep it short and sweet. For dialogue application requiring very long conversation, summarize or filter previous dialogue. Long conversations are hard to follow for humans and AI alike because it's hard to remember multiple topics, turns, and details. I'm sure you may have seen this issue of, this conversation is too long. And this is because that when you have a long conversation, again, as we've discussed, these models have what we call a defined context, a certain amount of working memory or space. And so as you have begun talking and you go past that amount of context, you essentially run out of space and the model can't really remember what happened at the beginning of the conversation. So by summarizing or filtering previous dialogue, you help maintain the context of coherence by highlighting the most important or relevant points and removing the unnecessary or irrelevant ones. The model also might create more engaging or enjoyable output because the repetition is then reduced. So generating summaries and then feeding that forward into this could be one way of handling it. So generating this summary could be one way of handling it. The other more complex strategy is to do what we discussed before, using embeddings to essentially have a much bigger database of knowledge that might be tucked away, and that you could eventually convert these to add additional evidence for future conversations. So the lesson is, keep it short and sweet. Summarizing or filtering previous dialogue can be done using keywords, phrases, and can be either automatically or asynchronously triggered, or done with embeddings. Embeddings databases require another step of understanding and knowledge. Because of that, summarization is what you might be able to accomplish within one of these models. So let's look into tactic 3, cut to the chase. Summarize long documents piecewise and construct a full summary recursively. So this third and final tactic for splitting complex tasks uses recursion to construct this summary. And let's break down what that means. These long documents are hard to read because it contains a lot of information and details. And when you break things down piecewise, it's kind of intuitive, right? So when you break things down piecewise and construct this full summary, you can help the model capture the main points by having it summarize smaller and smaller bits of text, such as paragraphs or sections or chapters, and then combining these summaries into a full summary. And then having the summary be more concise and coherent because there's less to really reference or less for the model to handle at one time. This is a big problem, as we've discussed, because models can have, as we discussed, models have a fixed context length. So it may not be able to handle the entire text all at once. But what you can then do is by having the recursion, so by having each section generate more sections, in each of the smaller sections themselves generating more smaller sections, you can then generate summaries for these smaller blocks. You can then feed back into the larger recursions and then re-summarize again. So this has been pretty effective, especially in earlier variants when OpenAI was training their models initially. So in short, let's cut to the chase. Recursively summarize these long documents to effectively manage a limited context length. Now that we've reviewed splitting the tasks, let's move to strategy 4. Think before you speak. Give the model time to think. The fourth strategy is to give this model time to think. So some tasks require more reasoning and creativity than others, solving a math problem, writing a poem, or generating a plot. So by giving the model time to think, you help the model generate better outputs and to explore different possibilities and solutions. And by also having the outputs more accurate and original, you can have reduced the chance of errors or cliches. For example, without giving it enough time to think, it's hard for a model to distill complex thoughts or ideas into a single, clear, coherent answer. Let's go into the tactics here. Tactic 1, don't jump the gun. Instruct the model to work out its own solution before rushing to a conclusion. So, since, for example, that some tasks might require more reasoning or creativity than others, evaluating a student's solution or writing a poem. So having a model work out its own solution before rushing to a conclusion can help the model generate more accurate and original output by comparing and contrasting different solutions and to help choose the best one. You can also make the outputs more reliable and explainable by showing the results processing behind the output. So although let's say you want to determine if a student's solution might be correct or not, compare asking whether student's solution might be correct or not. The assistant might say, "Oh, this answer is correct," and not really have worked through the results because the focus may have been directed to, is this student answer solution, is this work correct or not, regardless of whether it actually is correct. But if you change your answer, or if you change your system message here by requesting model work out your own solution first, then compare your own solution to the student solution, and then finally evaluate if this solution is correct because whether it matches or doesn't match your own output. And explicitly tell it, do not decide correctness until the model itself has solved the problem. Would actually help break this down into, right, it leverages these subtasks, as we talked about before, steps it through, and then answers it at the end. Tactic 1 feeds into Tactic 2, show, don't tell. Use inner monologue or a sequence of queries to hide the model's reasoning process. The first tactic showed that it's something important to reason in detail about a problem before answering a question, but you don't want to reveal the model's reasoning to the student until the student's actually answered the problem. So to not give away the answer too early, again, where you actually have to space it out, this inner monologue can be a tactic to really mitigate these issues. Again, the focus may be towards the user interaction. So in this example, you see that the steps 1 to 3 are have broken this problem into subtasks. You then hide the results into 3 triple quotes, or rather you hide this into triple quotes and don't display that to the student, but then you write on the back end that you can provide a hint, and instead of hiding steps 1 to 3, you then reveal step 4 saying here's where the hint may apply, generate the hint dynamically, but actually present this to the user. Alternatively, you could have a sequence of queries. So all except the last have the output hidden from the end user, and then stepping through step by step, and then revealing at the end, here is the answer, or here is an incorrect answer and what you want to advise, or here is the correct answer and how do you want to react. So after these first two tactics, and in context of strategy 3 splitting into subtasks, let's look at tactic 3 here. Did I miss anything? Ask the model if it missed anything on previous passes. So there are times when this short context may result in incomplete results where not everything was done as accomplished, right? And so you're splitting into subtasks, you're breaking them down step by step, and then you're asking the model to reason through it, and the model may terminate early for many reasons. In this case, you can explicitly ask, did I miss anything? So here, well, your initial suggestion is you're provided a document, you're asking for, selecting excerpts, and then you'll note that the example has some results, but you're not sure if they're complete. So you then have a follow-up confirmatory check of, are there more relevant examples? Take care not to repeat the ones you've already extracted up above, and then iterate on your task as you've highlighted it. So iterate on the completion of the previous subtask. So these 3 tactics wind up thinking before you speak. Let's move on to strategy 5. Give me a lever long enough and a fulcrum on which to place it, and I shall move the world. Archimedes. Use external tools. Strategy 5. These external tools or applications or services that can provide additional information or functionality for the task you want the model to perform. And using these external tools can help the model leverage existing knowledge by offering a wider context length or data. And they can also make the task easier. They give the model access to more powerful tools with different strengths and weaknesses, and make the task easier and faster for the model because they reduce the need to do everything from scratch. Let's go into the first tactic. Context is king. Use embeddings-based search to implement efficient knowledge retrieval. A model could leverage external sources of info as provided if it's provided as part of the input. You can give the model a chance to use external data by looking at, for example, a text embedding. So essentially building what we call vectors, where you distill essentially the text in a document into a string of ones and zeros. And similar strings or knowledge can be closer together than unrelated strings. This lets you break apart a big text corpus that could be beyond your context length, again, your limit, for example, of 8,000 tokens in GPT-4, into something that's much, much larger. And you're able to more efficiently leverage this within your existing context length. And once you do vector search, you can then find the correct embedded chunks of text that might be most related to the query, i.e. that's something that might be closest in the embedding space. So use these embedding search and these vector databases to more efficiently distill knowledge. That leads us into tactic 2. Leverage different strengths. Use code execution to perform more accurate calculations or call external APIs. You can't expect a language model, such as GPT-4, to do arithmetic or long calculations. This isn't what the model is trained to do. It's like asking a poet to do theoretical physics or asking a mathematician to write a sonnet. That's not what they're focused on doing. So in cases when you do need to use this though, consider that you can have a model write code and run it and have that run in the backend instead of making the own calculations. You can have, you might be able to generate code such as, you delimit it, for example, use delimiters to identify what the code would be as before in strategy 1, and then using the output of that code to be part of the input for the next query. So like these triple backticks here, you can run this Python code, or for example, having it call an external module to accomplish this task of sending messages to a friend. And big warning to those of you who may not be aware, as you've heard of, running code has the potential to be incredibly unsafe if you don't protect yourself. What happens if malicious code is created? It's hard to control that, so it's nothing that is generated can be assumed to be safe. As a result, consider running this in what we call a sandbox, something where if anything goes wrong, it's not going to mess up the rest of yours. So that limits the amount of harm a single bit of untrusted code could cause. This feeds into tactic 3, get functional. Give the model access to specific functions. the API actually allows you to pass in a list of descriptions as requests. So you can then generate these arguments to say, let's call specific functions that you can then feed back into a model in the following request to close the loop. So you generate essentially this call to this outside function, have the API generate that in, for example, a JSON format, and then call the function, then twist the output back into the model in the following request and close the loop. Check out this link in the function calling where to both call the function and respond with JSON. Last but not least, strategy 6, the scientific method. Test changes systematically. The sixth and final strategy is to test changes systematically. Changing the prompts can have unpredictable effects on the output. You could improve or worsen the accuracy, the creativity, or even the coherence of the output. Testing these changes can help the model evaluate the quality and the impact of the change by measuring and comparing before and after the changes. So think of what they call good evaluations. Good evals should at least be representative of what you might expect to encounter. You want to consider that you have more test cases to make sure that you have enough statistical power to assume, do you actually have a change or not? Because if you've insufficiently tested it, you might not detect a change. And lastly is you want to build these tests to be easy to automate or repeat. How could you build this test so that you can run it without having too much manual work on your own end to help encourage, remove friction and have you do more of these tests? And you can have these evaluations be done by either humans or compute, or you can combine the two. Consider using OpenAI evals to create a framework to automate these. Otherwise, you could have model-based evals to understand when ranges of outputs could either be equally high or differentially high in quality. And what is being evaluated is often fuzzy and shifting. Next, this would require, again, quite a bit of experimentation. So let's talk about tactic 1, the golden rule. Evaluate model outputs with reference to gold standard answers. If you need to test your model on a specific task, build these evals like we've discussed before. If you can build them off of known answers, this helps strengthen both the answers and strengthen your evaluation thereof. So by saying, here is a specific test in a system message, and then using subtasks and working through the evaluation, and then finally offering the results in a parsable format so you can record them in a unit test, you can then consistently test how well your model prompts have performed to this evaluation. So this lets you build consistent, repeatable evaluations, but also do that with the model itself to check itself for internal consistency. Conversely, you could also use other variants of these model-based evals. So for example, for more complicated, instead of if your task may not be a yes-no task, you might have to have a overlap tracks that considers where the differences or contradictions may be. So that wraps up the 6 ideas that OpenAI put forward in their recent guide for prompt engineering. But I want to offer some thoughts on this skill overall. I think we've all seen different news articles where people are getting these big flashy jobs. But when I was watching this recent YouTube video on how, for example, Microsoft is building Copilot into Visual Studio Code, I want to notice a couple things. Here's a clip. Let's listen to what he says, right?
Talking about flow. Who here spends hours crafting perfect prompts for the AI just to get help? Yes. Flow these days is also about avoiding long, winded prompt crafting and code responses buried in long AI responses.
The focus of this clip is that they acknowledge they don't want a user spending all day begging the model to give them the results in exactly the right way. They want the AI model to get out of the way, actually, and to build it into the workflow, to be very transparent or to be very conformative. There is no silver bullet. There are quite a number of limitations towards it. It's a powerful and useful technique to improve your performance or utility thereof. Some of the big things are, one, it's going to be oftentimes trial and error. You can accomplish a lot of new things with these new tools, but it's a bit of an art and a craft. The problem is that you have to probably experiment with different prompts and outputs and models and to find the best one for your task and your model. So you can realize that this could be influenced by the biases or errors of the model. Let's look at the very top of their OpenAI page. And I think, right, as you've noticed, this is very task and model dependent. So it's model dependent. So just as it used to be a big thing for us to know how to use Boolean search back in the early 90s, this is a skill that you're going to add to your repertoire. So, for example, some of these models only work with the most capable model, GPT-4. Maybe, again, not all of these tricks work with all models. Be aware that biases or errors can exist in both the model and the data. The prompt engineering is not neutral or objective, but it's subjective and relative. And so then the outputs might also be biased based upon that. And so I think as you have to be aware that you have potentially bias in your data, that you may not actually receive the performance you want in all circumstances. And since I work in healthcare, be advised that potential harms or risks of output could impact someone else's life, right? These can have wide-ranging impacts and effects that you may not want to overlook. And additionally, as these AI models become more and more capable, there may end up being less and less need for prompt engineering overall, or the role of such may actually evolve. So we don't know yet, but I think the lesson is there is no silver bullet. Again, prompt engineering can be very powerful, but also have significant limitations and challenges that you need to be aware of as you end up building your use case. Try to be specific and thoughtful when you try to overcome, to avoid, or mitigate these limitations and challenges. Thanks for your time. Please like and subscribe, and ask any questions you have below. Happy 2024.